Welcome, welcome, welcome. In this video, we're going to discuss the topic of coding theory. So in short, coding theory is about trying to send messages and make sure that those messages are correctly received. So for example, if you're sending a phone number, you want to send that exact phone number during the transmission. And there's all kinds of errors that can occur electronically during a transmission, and we're going to discuss those errors, how to deal with them, and whether we can just kind of notice that an error occurred. That's called error detection, and maybe even go beyond the detection to correct it to get the original message back, even if an error had occurred. Okay, so we're going to use the following problem to get us started with this topic. It's called the wrong number problem. And I've made up some of the details about it to expand along what we're going to be doing. So I made up this town called Five, and in this town, people are getting very upset. So in Five, they worship the number 5. The phone numbers are 5 digits long, and they only use 5 digits altogether, just 0, 1, 2, 3, and 4. That might remind you of modular arithmetic with mod 5, so they use the mod 5 remainders. But lately they've been having an issue in this town of 5. Many phone calls are resulting in wrong numbers. So you try to call someone, you type in the number correctly, but you'd call the wrong person. So how can we deal with this? So after some further investigation, they've discovered that what's going on is 2 adjacent digits are switching. So if you dialed 0, 1, 2, 3, 4, you may actually end up calling the person at 1, 0, 2, 3, 4. So notice the 1 and the 0 switched positions, and we call this the switch bug. So each type of error will have a particular name so that you know what you're talking about when we say the switch bug, and there's going to be a digit error and a smudge digit error. So this one is the switch bug. So this town of 5 does worship the number 5, but this problem has gotten so bad with the switching that they're going to go against all of their beliefs and add a 6th digit to the phone numbers. So when this is done, in coding theory, we call this a check digit. So a check digit is an extra digit that's being added. It's not being added to provide any further information to the receiver, whoever's receiving your message. Like you just want to send 0, 1, 2, 3 along and then call the right person. You don't really want to add a 6th digit. But the 6th digit, this check digit, is just there to make sure that the 5 digits that are originally there get across correctly. So that's why we call it a check digit. We're using it to check things. So the 6th digit will still be subject to this switching. It's not immune to the switch bug. So after we add this check digit, the problem should be fixed in the following way. So called numbers that experience this switch bug that we're talking about here will result in a non-functioning number. So the caller will be informed that the switch bug has been detected and to please redial the number. So it might be something like you type in 0, 1, 2, 3, 4, and the check digit, let's just say it's 3. You call that number and boop, 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 a switch bug occurs, and you get an automated message saying, please try to call again. The switch bug has occurred. So that's what our fix is going to look like. Now let's just highlight the difference between detecting and correcting. So here, when we're just saying, hey, the switch bug has occurred, try again, that's just detecting. So if we were to correct, you would send your phone number away, it would detect the message as having the switch bug and be able to fix it. So we're not worried about fixing it here. Our job is to help the town of 5, and we're going to design a mod 5 congruence equation that picks this check digit for us. Then everyone will get their check digit added to their phone number. And the congruent should be true when any new 6-digit phone number is plugged in. So if you have a correct phone number and you plug it into this congruence, it should be true. But it should be false after any switch bug occurs. So in that sense, this mod 5 congruence can detect when the switch occurs. If you have a good phone number, plug it into the equation is true, you say, yep, it's a good phone number. If you have a phone number that has had the switch bug occur, you plug this switched error into the mod 5 congruence, and it should come out as being false. That's how we can get our error detection. So pause the video now, give this a try to digest what's going on here before we reveal what the solution is. Okay, so what we're going to do is take a phone number and call the first digit A, and the next digit B, and C, D, E, and then the final digit, we'll call that X, the check digit. Now, after some careful thought, you may have realized that if you set up a congruence so that the coefficients are alternating or different, so we want a mod 5 congruence, so we're going to pick A with some coefficient, let's say C, let's say C1, and then plus B with some coefficient, let's say C2, and so on. So C3, capital C, plus C4, capital D, plus C5, capital E, plus C6, capital X. And we want all of this to be congruent to 0 in mod 5. Because in the town of 5, we're just using digits 0 to 4. So the idea is that when the switches occur, like A, let's say switching with B, if we pick the C and the C1 and the C2 to be different, then we're going to notice when A and B change because we're going to be multiplying it by something different. So this is a key way that mathematicians have found to deal with the switch bug. And maybe pick the easiest possible way of picking those coefficients. How about we just pick an alternating combination of like 0 and 1. So C1 is 0, C2 is 1, and so on. Okay, so that would give us a much simpler congruence as a way of picking X. So X is always chosen so that this congruence is 0. Let's try to prove that this setup will always detect the switch bug, no matter which 2 digits are getting switched and no matter what the digits are. So since we alternated the coefficients 0 and 1, 0 and 1, 0 and 1, it doesn't matter which 2 digits we pick to swap. The only thing is we, of course, want to pick 2 digits that are different. If like 1 and the digit 1 swap, there is no error anyway. So let's start with that. Let's assume in our proof that A switches with B and A and B are different digits. So when this switch occurs, what we want to have happen is the equation or congruence that we have above. We want it to no longer be true. It's always true to begin with. We pick everyone's phone number, so they take their second digit, they take their fourth digit, and they take their check digit, and everyone's phone number gets chosen, so they have 0 in mod 5 when you add those digits together. But now we want to make sure that we no longer get 0, so that we can say, yes, this equation is false, and yes, a switch bug has occurred. So let's write down, after the switch occurs, you would be testing A, because it would now be the new digit that's in the second position, plus D, plus X. Let's see if we can think about that expression being not 0 anymore? Well, this expression in mod 5 is certainly different if we were to sub in B for A, because they're different digits to begin with. So if you put the B back in, you get something different. But B plus D plus X is congruent to 0 in mod 5. So A plus D plus X, after the error has occurred, we no longer get 0. So this proves that we'll be able to detect any switch. And of course, there is some other symmetric scenarios, like you could switch with the D or switch with the X, but we don't need to test every single symmetric scenario. So therefore, we've detected the switch bug. Okay, so before we finish up this video, I want to give some definitions of coding theory. The very most important definition that you can talk about is what is a code. So a code is a collection of code words. Okay, wait a second, what is a code word? So a code word is a word made of digits or letters or other symbols. So you just make these words, and when I say word, I don't really mean an English word. What I mean by word here in quotations is that, it can be anything that means something to a sender and receiver team. So it could be letters or combinations of symbols, numbers, whatever you like. So in that sense, the code is just a bunch of stuff that means something that we can send. Now, if you think about, let's say, the English language, we could view that as a code. Like maybe everything in the dictionary, all the words that I could possibly say, are in our code. And then, the code words are the individual words. Now, if I ever said something outside of the code, if I started talking in a different language, then you could say, oh, that's not part of the code. And that's really how we do error detection. We only send things that are in the code. When I'm speaking in English, you expect me to say actual English words that communicate things to you. So what's the idea with the wrong number problem in relation to codes and code words? So in the wrong number problem, the code is like your phone book, your collection of all 6-digit phone numbers. The code words are the individual phone numbers. So here's a question to just play around with this definition above. How many code words are there in the code that we just used to solve the wrong number problem? Or in other words, what is the maximum number of people that could live in the town of 5, and each one of those people having a different 6-digit phone number? So let you think about that for the moment, and we'll give you the answer right away. Okay, so the idea is that A, B, C, D, E can be picked to be anything from the set 0, 1, 2, 3, 4. Now, while we have a choice over A, B, C, D, E, we do not have a choice over X. X must be the digit that makes B plus D plus X congruent to 0 in mod 5. So how many phone numbers do you get? Well, there's 5 choices for A, 5 choices for B, C, D, and E. So there's 5 to the power 5 phone numbers. Or in the wording of coding theory, there is 5 to the power of 5 code words in this code. Okay, thanks so much for listening, and we'll see you on the next video.